and they need not be in conflict, they can also support each other. That's the idea. And so similar to this, there is also two possibilities. There's an interesting paper by Rodam Narasimha. I think many of you know who this famous aeronautical researcher. I think many of you know, right? He was also a professor at IISc.
He's from BC.
Okay, very good. Okay, he's from USC. Very good. Okay, so I didn't know about that. Okay, so there's a very famous, distinguished scientist in Bengaluru. Okay, and his name is Rodam Narasimha. He wrote a very interesting paper in 2002, I think, in a magazine called EPW. Okay, it is a research journal for social sciences, and he talked about how the Indian tradition had. Instead of the deductive logical positivism, it had what he calls computational positivism. I will explain what this is. Okay, so I found a very interesting perspective from Rodam Narasimha, and I'm going to use that as a basis to explain some of the work that happened in this country in terms of computer science. Okay. So what is, first of all, let's try to understand what positivism is. What is positivism? This is facts are only possible knowledge, objects of knowledge, and science the only valid knowledge, no metaphysics. What is metaphysics? Those things that we cannot see and let us say we postulate the existence and somehow base our theories etc. based on those things. A good example of metaphysics is the fact that we postulate that some God exists. Okay? Nobody has seen this amazing thing, but still we postulate and explain a lot of things based on that. It's like in your, some of you might have heard about hidden variables, right? If you do HMM, what is HMM? Hidden Markov models, right? Basically, you can't see those hidden variables, but it's still postulated, and based on that, you come up with some explanations. Okay, and to put it crudely, I think you can call it metaphysics also. Certain things which you assume to be there, okay, but you can't put a finger on it and say this is it. Okay, it's sort of there. Okay? So the question is, what positivism says is that don't tell me all this hidden stuff, and from there you deduct it. Or like for example, astrology, like you would say, somehow that. Some planet somewhere is going to affect your behavior. Okay? They don't explain how it happens, but they say it exists, it happens. That is an example of a metaphysical belief. Okay? What these people are saying is that I don't want all this stuff, I just want to know what the facts are, and based on the facts and deductions and whatnot, I want to proceed. Okay? That is what is positivism. Okay? And there was a famous school in the 1930s. It is called the Vienna School, and there's a collection of scientists, mathematicians, and philosophers, including quantum mechanics people, logicians, philosophers, all these kind of mathematicians, all these guys were there. And they believe this particular thing, that you can only have, verifiable facts, deductions from there, and everything follows. And mathematics is a prime example of that. Everything starts from axioms, from axioms you get everything. Right? And this particular thing was finally, this particular notion that is sufficient to handle everything was destroyed by a person you might have heard about, Gödel. Gödel finally showed that it is not possible to have a purely this kind of perspective. Logical positivism is only halfway there. It cannot do the proper job. What did Gödel prove? He showed that there are true statements which cannot be verified. Okay, that is a great contribution of Gödel, and essentially it means that all this stuff about so basically it says a statement that cannot be verified automatically had to be meaningless. Okay, that is what logical positivism says. But then Gödel showed that there are true statements which cannot be verified. Okay? Because in any mathematical system of some reasonable complexity, there are always theorems which are true but cannot be verified. Okay? So that is Gödel actually showed this, and therefore this logical positivism is basically, in some sense, a dead end to some extent. It can do certain things, but it cannot go all the way. Okay? What is interesting is that there is a similar analog in the computational world. Okay? You cannot capture certain things completely. For example, logical positivism also can only go that far, okay? But it cannot capture everything. Similarly, there is some complex system out there, and you cannot capture every single thing that happens there. Okay? It's difficult, but you can keep pushing yourself to capture more and more aspects of this till you can get to some reasonable extent that is useful for you to understand the whole system. Okay? So, in a sense, what you can say is that a computational positivism is a model by which it says that it's true that I can understand everything, but I have certain models, I'll use the model to compute certain things, and I'll see how close they are with respect to the observed things. If they are close, then I'm quite happy, I can say that's good enough. If it is not close, I refine my models and keep computing. Basically, computation has the engine by which you can come up with newer insights and see if it corresponds to the reality. Okay? I'll give examples of this soon. Okay. So, in a sense, what Pradhan Narasimha says is that the Indian tradition was different from the tradition coming from, supposedly from Greece and other European countries, which is basically based on deduction. Euclid was their model. Euclid is basically some axioms, right? And from there everything is derived. Okay. Now, this one is held to be in our tradition or in the computational model that axioms only go at small amount of distance. They can't really do everything because the real world is far more complicated than being deductive. Okay. So, a good example of, I would argue as part of this is that we had a very good example of this computational positivist attitude, and that of, for example, Panini. Okay. I think many of you have heard of Panini. He is a famous grammarian in this country, and a lot of people have said that they say that the greatest monument intelligence, human intelligence. He is an example of the greatest monument human intelligence. That's what some people have described it as. Okay. And what is this issue? There is a living language in those days. This is about 5th century BC. Sanskrit language, it was considered a living language at that time. There is also an older language, the Vedic Sanskrit. The question is how to describe the Vedic Sanskrit and the current language Sanskrit at that time completely as possible. Again, this is only certain aspects of the syntax and the morphological aspects, not the semantic aspect. No semantics here. Semantics is somewhat more difficult, okay, because it keeps changing with time. Okay, whereas the syntax and morphological aspects. Okay, some of you who have studied Kannada here, right, would know something called sandhi, for example. How to capture all the sandhis, how to capture samasas, how to capture the particular, vibhaktis, like all these things. Like how to capture all those things in a very concise and powerful way, so that it is as complete as possible. And it's believed that there is still no language which has been captured as completely and as accurately as Sanskrit grammar by Panini. Till today, no language has it compared to Sanskrit. And basically, what you can say, Panini's attempt was to describe the living language completely. Okay. And again, what is the issue here? Just like what we talked about, right? You have a grammar, see if it corresponds to reality. If you don't have a grammar which corresponds, you refine it. Okay, till you get it mostly correctly. Okay, and the refinement also happened. Not only Panini did a great amount of stuff, almost he captured probably 99.9% or more. But later communicators, later grammarians, like for example Patanjali and Katyayana, they actually, some minor things were, very, very minor things which Panini could not handle, were also handled by, or explanations which were. If Panini had done it, but there was some confusion, they actually cleared the confusion by explaining how to actually handle it. Okay. So the question for us is it an example of computational positivism? Okay. Basically, in a sense, what is, you have a real system like a language, right? Complex language, right? Or Kannada, for example, and it has got a lot of people are using it. You want to capture it reasonably completely, okay? And you do it by having certain theories, seeing how well the theories correspond to the reality, and then refine it till you get it mostly right. Okay? So that is what I think Pradhan Narasimha is talking about, and he says that this is characteristic of our tradition. Okay? And I would like to explain this a bit more completely. Okay? Again, let's look quickly at a few other. So I'm going to briefly first, what I will do right now is take the Panini's grammar as an example of a good example, and I will not go into detail about Panini's example because it is well understood mostly. So I'll just touch upon it, but I will move on to other examples. Okay? So the Panini's example is a starting example, but I will not spend too much time on it. Okay? First of all, if you have heard of Patanjali, he also not only supposed to have written on yoga, right? But he's also supposed to have written Mahabhashya, which is basically the commentary on Panini, okay? The Ashtadhyayi, okay? And what does Patanjali say? Language is innate. That is, it is part of human beings. You don't have to teach language to, sorry, I shouldn't teach. It is sort of wired into your brain. The DNA has got it, okay? And therefore, it's easy for us to learn languages. Okay? Whereas you can't make an ant learn a language because that its DNA doesn't have that capability. Okay? So, and this particular view was popularized by Chomsky also, much later, almost something like 20 or 25 centuries later. Okay? You might have heard of Chomsky. Okay? So Patanjali actually argues that if you have a language, it's easier to come up with a system which generates correct expressions of the language than to enumerate all the wrong ones also and then separate out the good ones and the wrong ones. Okay? He says that better to explain everything by generating all the correct ones first. Okay? Don't have anything which just generate all of them and figure out which ones are correct. Okay? Because that is a hopeless task. And the question is, how is this enumeration to be done? Okay? Does it make sense to list them one by one? Okay? Again, Patanjali says this is too difficult. Again, those of you who have studied the theory of computations, all these issues are there. Okay? There's something called recursive languages, recursive enumerable languages, okay? And then undesirable languages. Okay? And essentially this is a recursive enumerable language. Okay? And so the listing part is difficult, and actually gives an example. Bruhaspati, the teacher of gods, taught Indra a work containing all correct expressions of Sanskrit, okay, for 1,000 divine years, which is equivalent to supposedly 360,000 human years. And still Indra could not finish it. Okay? That's, so Patanjali argues that you can't do this. You can't do by enumeration. It's hopeless. So what do you need? You need something else, and that is what is called generative linguistics. Okay? And this was the first and the most sophisticated, the first in the whole world, and the most sophisticated form. Even today, one of the most sophisticated forms for any language is Panini, even today, okay? Because it has got 4,000 rules, and it has done a fantastic job of capturing the whole language. Again, as I'm telling you, I'm not going too much into it because there are whole courses on the subject you can study, okay, various parts of the world. So I'm not going to go into it. I'm just giving a starting example. Okay? And Panini, if you look at it, is an example of an expert system. Some have heard about expert systems. And what does the expert system have? It has got code, it has got data input, data output, and control. Okay? What is a code? Code is basically sutras. Okay? And mostly it's all rule-based. I'll briefly mention what that is. Okay? And mostly declarative, stateless, but some places imperative. That is, there is some state. Okay? And what is the input? Dhatu patas. Dhatu patas are basically the list of the verbal forms, for example. Okay? There is some kind of data which is being used as a. It's like almost like the initial starting points, axiomatic things. Okay, you start from there. Okay, okay, and data output. These are the pada. Pada means these are the words of the Sanskrit language, right? For example, if you take Rama as a word, right? The various vibhaktis, right? And if you add it, you get various forms depending on which vibhakti it is, right? So those things are generated. Those are the padas. Okay, and not only that, you can also get gender. And also accent. But accent was a very important part of Panini. Okay? Of course, the current Sanskrit doesn't have that much place importance on accent, but Panini's grammar, because it had to capture Vedic grammar, it also talks about accent. And there's also a control. Okay? I think if you studied expert systems, we have something called a blackboard architecture. Some of you might be familiar with this. And basically the thing is, it tells you in what order the rules fire. Okay? And again, Panini has got some amazing technical devices for all these things. And you'll see that there are 8 chapters in Panini. Up till the 7.5 chapters approximately, any rule can be applied anywhere, anytime. Okay? But the last half, once you enter that particular section, you have to exit there. You can't apply any of the earlier rules. Okay? So there's certain ordering in which the rules have been set up, and if you do that, you get something interesting. Okay? Otherwise, Panini doesn't guarantee it. Okay? So there is some very careful thinking about all these things. What is called termination. In a rule-based system, you need to be able to say that when you start the derivations, you finally terminate. Okay? And so there is some effort has been put in figuring out how does it terminate. Okay? Again, I don't have time for some of these things, but it turns out Panini can be, his grammar can be considered as what is called a term rewriting system. Okay? And there is something called post-production systems, which is, my understanding of Panini is that it is composed of, it is like a context-sensitive grammar in Chomsky hierarchy, for example, plus it has got some elements of post-production systems. I don't have time to go into some of these things. Someday, if we can probably talk about it, but right now I can't do it. Okay? So it turns out to have elements of both the context-sensitive grammar plus post-production systems and various interesting technical devices for termination. I already mentioned it. Rule inheritance, for example, if there is a particular rule and it says that it has got some conditions, then there is a grouping of the rules so that the same conditions that are applicable here are also applicable for all this below also for some time. Okay? That is some grouping of rules are also done. And is there a way to show this lower thing also? and slightly up, and with context-sensitive application of rules, okay, exceptions. Basically, it turns out there are, yeah, definitely, okay. And it turns out that there is a major rule, and then you have exceptions, and then that itself will have exceptions. So there are nesting of exceptions. Okay? It's almost like if you studied Java, you have some code, and then an exception code is there. There could be exception code within exception code. Okay, so how to have a hierarchy of these exceptions? Okay, so those kind of things are also there. Again, as I told you, I'm not going to go into too much into this because it requires the whole course to do some of these things. So, but roughly the Panini Sutra forms are of the following form. Again, don't bother about these things. It is roughly the A, B, C, D. These are the 4 components to sutras. Not all of the sutras have all the parts, but the most general one is this. And it basically says B is replaced with C, okay? And A is deleted in the context of D. That's what it is. Okay? This is the most general form. And interestingly, if you have studied languages, there's something called Backus node form, BNF, right? BNF has got some meta-linguistic characters like colon equal to, right? Colon equal to, some of you might have seen it, okay? That's an example of something that is not part of the grammar, but it helps you to figure out what is the right-hand side and left-hand side, okay? Now, Panini didn't use such things. He used actually the devices available in the language itself. So basically, he would say that if you have a particular vibhakti, okay, right, that vibhakti will tell you which one is A, which one is B, which one is C, which is D. For example, if it is the Shashti vibhakti, the 6th genitive case, that means it is A. Okay? Because from G generates, that is B generates C. So it is B is in a generative position. It is the 6th vibhakti, Shashti vibhakti. Okay? So if you take that rule, find which is the Shashti vibhakti. That is the B part. Okay? Now, if you look at the nominative, okay, Prathama vibhakti, first one, okay, that is going to be the C part. Okay. If you look at A, ablative part, the one which is cut out, okay, that will be A. Okay. And D means that is you will find that is a context-sensitive grammar. That means in what context can it be done? Okay, that is the D part. That's located in this location. Saptami vibhakti. Okay. So that's basically what we do. Okay. So this is roughly the thing, and it is a very deep and interesting thing. It is mind-boggling in its precision. Okay. It is so unbelievable that unfortunately we as computer scientists in this country have not paid our debt to Panini because we don't even know anything about it. Okay. It is a shame that we don't know anything about it. Okay. But if some of us have that aspect of Rushiruna, we have to study some of this and understand some of these things. Okay. I am doing a small little bit, but I am also ashamed of my ignorance about this particular aspect. I think we need to do a lot more research, a lot more understanding about these things. Now, again, I'm going to conclude the Panini part soon because this is not the main part of this particular talk. So, actually, it turns out that there are very lot of fascinating devices in this particular grammar. One thing is what is called an ith part. What is an ith? It's some kind of meta-linguistic construct. Basically, when you have certain rules, this rule has to change to something else. And to make it go in particular directions, you add certain non-grammatical constructs not present in the language so that you have certain markers, and these markers will finally be, let us say, taken out so that finally you have only expressions in the language. Okay? So basically the idea is you start with something, you add some non-linguistic aspects of that into that, okay? And then finally those non-linguistics are taken out. Okay? Finally you have only expressions that are part of Sanskrit language. Okay? So it's something like, suppose to make a very crude example, let's say that you're talking about Sanskrit grammar, and then to explain it you put some English words here and there. Okay? And once you have derived it, you finally have to throw out the English words out. Then only you have expressions in Sanskrit. You don't have, otherwise you will mix English and Sanskrit. It is not a part of Sanskrit language. Right? So similarly, you have certain, from a grammatical or linguistic point of view, or generative linguistics point of view, you need to put certain meta-linguistic characters, okay, which are required. Okay, that's what is needed. And if you look at the thing, so you need to know, when you are applying the rules, you need to know what is actually part of the language, what is not, which is what are meta-linguistic characters. You need to know that as you are doing the derivations. And you'll notice that there is how to recognize something as a meta-linguistic character or not is essentially something like if they have space for some of your finger. Actually, some of this info. Okay, if you, I don't have time to go through any of this thing, but there is a fairly deep let us say, analysis of when something is a metalinguistic character, when it is not. Okay? So all these are encoded in the language itself, in the grammar itself. Sorry, not language, in the grammar. Again, some of you might have seen syntax diagrams for computer languages. If you take the Sanskrit language as given in Panini, it turns out to have something like this kind of syntax diagram. What it means is that it captures the recursive aspect of language quite completely. Okay? For example, you can start with a dhatu, that is a verbal root form. You can add a krut suffix, then it can become a pratipadikam, then it can be add a sup, then it's basically you got a noun form, for example, and then you can add a sup for it, you get subanta, and then you can go up to this, and you can keep going round and round, then come here and come like this, come like that, and continue. It means that what Sanskrit has got is an ability to construct very, very long, let us say, phrases, but because you can go round and round and round till you get it, right? And there is famous examples of the 400 long sequence of these things. Okay, there is things of this kind. Okay, and this is captured quite completely. Okay. So basically, I'm just giving the first example. Question is about computation observation. When agreement constitutes the only form of valid knowledge. What I can talk about? We have Sanskrit language. It is a spoken language in those days. There's an older form Vedic language, right? And we need to figure out whether my grammar, what Panini has come up with, does it capture it completely or not. Okay? Agreement is the only thing that is acid test. No metaphysics. Okay? No attempt to say that it is because of X, Y, Z, which is not there. No hidden variables. Okay? The grammar should capture everything. Okay? So, models, logic, metaphysics are either secondary or not relevant. Models may not be unique. For example, it may be possible that Panini came with one model, somebody else can come with something else. If it is more precise, more complete, that is a better model. Okay?